Welcome you all. Today in this video we are going to learn about 2D reflection. Now what is meant by this reflection? Reflection is nothing but the mirror image of an object. Whenever you try to obtain a mirror image of an object, the result is a simple reflection. Now how can you obtain a mirror image of an object? It is quite simple. To obtain a mirror image of an object, you can simply do a 180-degree rotation. That means whenever you try to rotate an object to 180 degrees, the result of 180-degree rotation will be equivalent to obtaining a mirror image of an object. So these two actions are same. Obtaining a mirror image is same as doing a 180-degree rotation of an object. Clear? Now let us see how this can be done. Consider you have a triangle with you, and at present the triangle is pointing towards this direction. Okay, so this triangle can be rotated to 180 degrees. Now at first I am trying to rotate the triangle by 90 degrees. So let the path of rotation be like this. So I am going to rotate the object in this path like this. That means I am trying to rotate the object in anti-clockwise direction. So at first, when this particular object is rotated by 90 degrees, definitely the object will become like this. Initially it was at this position. Once the object is rotated in the anti-clockwise direction by 90 degrees, it reaches at this position. Again I am trying to rotate the same object by 90 degrees again. Okay, so from this position I am again rotating the object in anti-clockwise direction by 90 degrees. This time the object reaches at this position. So initially object was at this position. After rotating the object twice by 90 degrees, it reached at this position. So I have rotated twice, and each time I have rotated by 90 degrees. So 90 into 2 becomes 180 degree. So this is a clear-cut case of 180 degree rotation. So when an object is rotated by 180 degrees, the result is quite similar to that of a mirror image of the object. So now the object is pointing towards this direction. Initially it was pointing towards this direction. That means a left pointing triangle has now become a right pointing triangle. And you already know that whenever you get whenever you try to obtain a mirror image of an object, the left and the right sides of the original object are inverted. Left of the original object becomes right of the mirror image, and right of the original object becomes the left of mirror image. So in this way you have rotated the right pointing triangle has now become a left pointing triangle. Hope the concepts are all clear to you. Now let us move on to different types of 2D reflection. We know that reflection can be performed in 3 different ways. They are reflection about x-axis, reflection about y-axis, and reflection about perpendicular axis. So these are the 3 different ways in which you can perform reflection in 2-dimensional frame. We will learn each of these reflection one by one. Let us now first move on to reflection about x-axis. Now let us consider this particular coordinate axis. The 2 different axes which are given are the horizontal x-axis and the vertical y-axis. And the object is a 2D object which is drawn before you. Now when this object is reflected about x-axis, the reflection will be obtained in this quadrant. We already know that there are 4 quadrants. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. When the object is reflected about x-axis, then this particular object will be rotated by 180 degrees about this x-axis. So 180 degree rotation is obtained, and the rotated object or the reflection of this object is obtained in the fourth quadrant. I repeat, whenever you try to do reflection about x-axis, you will get a 180 degree rotation of an object, and the rotated image or the reflected image will be obtained in the fourth quadrant, like this. So typically the original image is in the first quadrant and the reflected image is in the fourth quadrant. What is the difference between these two quadrants? Typically we know that in first quadrant all the coordinates, that means x coordinate and y coordinate, are both positive, whereas in fourth quadrant only the x coordinates are positive but the y coordinates are negative. So the relationship between these two objects is like this. When the object is reflected about x-axis, after reflection the object will be having same x values but the y values of the object will become negative. I repeat, after reflection of the object about the x-axis, since the x-axis is common, you can see here the x-axis is common. So after reflection, the reflected image will be having same x values as that of the original object, whereas the y value of the reflected image will become negative, because where the original object lies, both x and y are positive, whereas when you can consider the reflected image, x is positive but y is negative. So this is because the equations are written like this. Equations are x dash equal to x and y dash equal to y. What does this mean? We know that before reflection the point P is having two coordinate values x and y, like this. So P is a point before reflection. It is having two coordinate values x and y. P dash represents point after reflection. After reflection the point will become x dash y dash. So initially it was at point xy. After reflection it became x dash y dash. So what is the way in which you can obtain x dash from x? Since this is a reflection about x-axis and there is no change in x values even after reflection, x dash is same as x. Therefore, I have written x dash is equal to x. What about the y values? After reflection, y becomes negative because the original image is having a positive y value, but after reflection, since the image is in the fourth quadrant, y becomes negative. So the relationship between y and y dash is like this. Y dash will be negation of y. So the equation is written like this: y dash equal to minus y. Okay, y dash equal to minus y. So this clearly indicates that the new x value will be same as the previous x value even after reflection, but the new y value will become negation of previous y value after reflection. So this is how reflection about x-axis is performed, and you are familiar with the equations. Now let us see how these transformation equations of reflection can be written in terms of matrices. So this is the general equation: P dash is equal to mx into P, where P is the initial point, P dash is the final point, and mx represents the mirror image of an object when the object is rotated about, or when the object is reflected about x-axis. I repeat, mx represents reflection about x-axis. M is for mirror image. Okay, so x, the suffix x represents reflection about x-axis. Hope you are clear with the concepts. Let us write the matrix values. We know that the initial point can be reflected about x-axis to obtain p dash, and p can be written as x, y, 1. P dash can be written as x dash, y dash and 1. There are three values written in the matrices. Why? This is a two-dimensional frame and we are representing this coordinate using homogeneous coordinate system. What is a homogeneous coordinate system? Representation of n coordinate system using n plus 1 coordinates. What is the value of n here? In two-dimensional frame, value of n is 2. Since n is 2, n plus 1 becomes 3. So, we are going to represent a two-dimensional frame using 3 coordinate values in such a way that there is no change in value. So the equations which I need are x dash equal to x and y dash equal to minus y. These are the two equations which I want. So how the matrix of mx means mirror image of an object obtained when the reflection is performed about x-axis. How the matrix can be written? This is a square matrix with 3 rows and 3 columns. Let us see how the matrix can be written. I repeat, x dash can be obtained when first row of mx is multiplied by this column matrix, and y dash can be obtained when second row of mx is multiplied by column matrix. Similarly, 1 is obtained when third row of mx is multiplied by column matrix. So let us multiply each row with the column matrix to obtain the values of x dash, y dash and 1. First equation is x dash equal to x. That means the value of x dash can be obtained by just substituting the value of x. So here in the first equation there are no values regarding y. Only x is there. To get x, x should be multiplied by 1. So I am writing a 1 over here. Since there are no parameters related to y, I am writing a 0 and the third parameter is also 0. Such that when you multiply the first row with the column matrix, you will get the equation x dash equal to x. Let us multiply 1 into x plus 0 into y plus 0 into 1. And when you multiply these values together, the result you get is x dash equal to x. Now let us write the second row. Second row can be obtained like this. I am going to write the values in such a way that when second row is multiplied by the column matrix, you will get the equation y dash equal to minus y. So in the second equation there are no values related to x. So at position x I am writing a value 0. Last value is also 0. But y dash should be equal to minus y. So y should be multiplied to minus 1 so that it becomes minus y. So I am writing a minus 1 here. Let us multiply the second row with the column matrix. 0 into x plus minus 1 into y plus 0 into 1. The result is y dash equal to minus y. Okay. So you got the second equation also. Now you need to get the third equation, which is 1 equal to 1. To get the third equation, we can see that there are no values related to x and y. So writing 2 zeros over here and the last row becomes a 1. Last row, last column, value becomes 1. Let us multiply the third row with the column matrix. 0 into x plus 0 into y plus 1 into 1. You will get 1 equal to 1. So in this way, the reflection about x-axis matrix is written in such a way that the equations remain the same, that is x dash equal to x and y dash equal to minus y. So this is the first type of reflection where you can obtain the mirror image of an object in the fourth quadrant and the reflection is made about the x-axis such that there is no change in x values, only the y values are changed. Before reflection the y are positive and after reflection y becomes negative. That means after reflection the object, the reflected image will be obtained in the fourth quadrant. So accordingly you can write the equations and accordingly you can write the matrices also. Proceeding on to the second type of reflection in two-dimensional frame, it is reflection about y-axis. So the first reflection was about reflection about x-axis. Now I am going to do a reflection about y-axis. Let us consider the figure again. This is the figure given. Two axes are there, x and y. Object is given to you. This is a two-dimensional object, and I am going to rotate. I am going to do the reflection about y-axis. That means about this particular axis. So typically after reflection, the image, reflected image, will be obtained in the second quadrant. Like this. I repeat, since this is a reflection about y-axis, the object will be rotated to 180 degrees about y-axis, and after reflection the reflected image will be obtained in the second quadrant. So the object transition occurs from first quadrant to second quadrant. What is the relationship between the first quadrant and second quadrant? Yes, in both these quadrants the y are same. That means there is no change in y values. All those points in the initial object will be having same y values even after reflection. But what about the x values? Before reflection, all the points in the object were having a positive x, but after reflection, all the points in the reflected image will be having a negative x. What is the peculiarity of x values? Before reflection, all the values were positive, but after reflection, all the points will be having a negative x value. But there is no change in the y values of both these images. That means even before reflection and after reflection, the y values of the objects will be same. So the equation can be written like this: x dash equal to minus x, which means after reflection x changes to negative, x becomes negative x, but after reflection y dash equal to y itself. That means there is no change in y value, only the x value changes to its negation. Value is not changing, only the sign is changing. You have to remember that value, but that thing, particular thing. Okay, that means even after reflection there is no change in y value. Similarly, there is no change in x values also. X values are also same, but only the thing is that the sign has been changed. Clear? Value has no change, the sign has been changed. Clear? In previous case also, where I explained reflection about x-axis, here also what did I say? X dash equal to x and y dash equal to minus y means after reflection x has no change, both the values of x and x dash are same, and after reflection y dash and y are same. But the thing is that after reflection the sign of y becomes negative, only the sign changes, value does not change. Okay, coming back to our current point, we were talking about reflection about y-axis, and we got the equation x dash equal to minus x and y dash equal to y, which means after reflection about y-axis there is no change in y value, but x undergoes a change in sign, x dash becomes minus x. So now I am going to transform these equations into matrix representation. Okay, we know that P has two coordinate values x and y, and P dash has two coordinate values x dash and y dash. P is the initial point and P dash is the same point after reflection. Now the general equation can be written as P dash equal to my into P, which means the initial point P when reflected about y-axis gives you P dash. Now reflection about y-axis is written as my. The suffix y indicates that it is a reflection about y-axis, and m is written to represent that reflection is equivalent to mirror image. So I have used the letter m. Okay, let us now see how we can write the matrix. P can be written as x, y and 1. P dash can be written as x dash, y dash, 1. Okay, let us write the matrix my. What is it? x dash can be obtained when first row of my is multiplied with column matrix P. Y dash can be obtained when second row of my is multiplied by the column matrix P. 1 is obtained when the third row of my is multiplied by the column matrix P. That means when each time each row of my gets multiplied by the column matrix, you will get the corresponding values of x dash, y dash and 1. So this time I want the equations like this: x dash equal to minus x, y dash equal to y. These are the two equations which I want, and the last equation is 1 equal to 1. Let us see how these equations can be obtained. So first equation is x dash equal to minus x. To get this equation, I am going to write the first row. First row values should be written in such a way that equation is x dash equal to minus x, and in this equation there are no values regarding y and last parameter. So at position y and the last parameter, both values will be written as 0. But I need to get a value minus x. X should be multiplied to minus 1. So the first value is minus 1. Let us multiply the first row with the column matrix. Minus 1 into x plus 0 into y plus 0 into 1, which means the result is x dash equal to minus x. Let us move on to the second row. Second row must contribute to the equation y dash equal to y. In this equation there are no values regarding x and the last parameter, so both those values will be 0. So the first element and the last element will be 0. What about y? Y dash equal to y. That means y should be multiplied to 1. Let us multiply the second row with the column matrix. 0 into x plus 1 into y plus 0 into 1. The result is y dash equal to y. So second equation is also obtained. Okay. Now let us write the third equation. Third equation is 1 equal to 1. So accordingly you have to write the third row such a way that there are no values related to x and y. So first two elements will be 0. Third element is 1. Let us multiply the third row with the column matrix. You will get 0 into x plus 0 into y plus 1 into 1. Value is 1 equal to 1. So in this way you have written homogeneous matrices of P dash P and my such that my is multiplied to P to obtain P dash. Even after representing the two coordinate system using 3 coordinates, there is no change in values of the equation. So in this way reflection about y-axis can also be achieved. Proceeding to the last reflection, which is reflection about perpendicular axis. This is the last and final reflection in two-dimensional frame. So let us move directly onto the problem. So the two-dimensional axis is given before you. An x-axis and a y-axis is there, and an object is there, which is a 2D object. And I am going to reflect this object about a perpendicular axis. This is the perpendicular axis about which I am going to do the reflection. So after reflection, this particular object will undergo a 180-degree rotation, and the reflected image will be obtained in the third quadrant. Okay, I repeat, reflection about perpendicular axis means object will be rotated on the basis of this particular perpendicular axis. So after reflection, the object will be rotated 180 degrees and the reflected image will be obtained in the third quadrant, like this. Now how are these two quadrants related? Peculiarity of the first quadrant is that in first quadrant both x and y are positive. But peculiarity of the third quadrant is that both x and y are negative. So initially the object was in this quadrant, which is first quadrant, and after reflection object reached in fourth quadrant. And the peculiarity of fourth quadrant is that here both x and y are negative. So how you can write the equations? That means before reflection, x and y were positive, but after reflection both x and y became negative. That means there is no change in value, only the signs of x and y have been changed. Signs are inverted. So how the equations can be written? Equation can be written as x dash equal to minus x and y dash equal to minus y. Which means after reflection, the new value of x will become negation of x. That means no change in value, only the sign of x has been changed. If x is 4, x dash will be minus 4. So there is no change in value, only the sign has been changed. 4 becomes minus 4. When the sign of two numbers are changed, 4 and minus 4 are extremely different. You know it. Okay. So x dash is transformed in such a way that x becomes negative. Okay. And what about y dash? Y dash also attains a negative value. Y dash becomes minus y. Okay. So before this transformation, that means before reflection the point was xy, and after reflection the point will become minus x minus y. So minus x is written as x dash and minus y is written as y dash. So both x and y will become negative because the reflected image is obtained in the third quadrant. Now directly moving on to matrix representation. We know that the initial point P, when reflected about the perpendicular axis, P dash is obtained. Reflection about perpendicular axis is represented by mxy because M represents it is a mirror image. Mirror image is obtained when reflection is performed about x-axis, and this mirror image is obtained when reflection is performed about perpendicular axis, and this perpendicular axis is the xy plane. Only because of this the suffix xy is written over here. Xy indicates a perpendicular axis xy plane. Now let us write the matrix. So the equations I want this time is x dash equal to minus x and y dash equal to minus y. Okay. Last equation is 1 equal to 1. So the first equation is x dash equal to minus x. It can be obtained when first row of mxy is multiplied with the column matrix P. And since the first equation clearly states that there are no values related to y, the value of y will be 0 and the last value of that row will also be 0. First value is written as minus 1. Let us multiply the first row with the column. Minus 1 into x plus 0 into y plus 0 into 1. Clearly equation becomes x dash equal to minus x. Writing the second row such that you will get the equation y dash equal to minus y. In the second equation there are no values related to x, so the first value will be 0, last parameter will be 0, value written over here will be minus 1, such that when you will multiply the second row with the column matrix, equation goes like this: 0 into x plus minus 1 into y plus 0 into 1, giving you y dash equal to minus y. About the last row, equation is 1 equal to 1. That means no values related to x and y, both are 0, last value is 1. Multiplying the third row with the column matrix, you will get 0 into x plus 0 into y plus 0 into 1. You will get 1 equal to 1. So in this way you have written the third matrix also, mxy. So this is how reflection about perpendicular axis is performed. So hope the concepts explained over here in this 2D reflection are all clear to you. This is all about 2D reflection. Please stay with me, support me, watch the videos and enjoy. Thank you.